Okay, this video is to clarify some of the things that didn't translate very well in class today because of some technical issues. I am using paint and my left hand with a mouse, so bear with me. It's not going to be all that perfect as far as neatness. We're trying to start off talking about proportionality, and first one is direct proportionality. Talking about two things that are directly proportional. I'm not going to worry about writing the word out. You guys know how to write the word. In fact, you have that slide. So, one example of direct proportionality, the one I was using in class was force and displacement with a spring. If we have this little spring here, and it originally has this length, but you stretch it out a little more, out to about here. So what you've done is you have displaced it by a distance x. Well, that spring is going to exert a force back on your fingers, and F, the force exerted by the spring, is going to be proportional to the distance x that you have displaced the end of the spring. That just means the further you pull it out, the bigger the force it's pulling back with. That's not an equation that we can work with. What makes it an equal sign, oh, that's messed up. Let me try that. Let me clean that up again. Sorry, again, I'm using paint here and left hand and a mouse. What makes it an equal sign is we put in a constant of proportionality, and so F equals K, the lowercase letter K, X. Now, mathematically, this is the constant of proportionality. In science, actually, there is some, this relationship with springs. This is called the spring constant, and it actually has some useful meaning with the spring. In fact, once you know that K for one spring, that K is true for that spring from then on. And that's how all these proportionality equations are going to work. You'll be told the relationship. A is proportional to B. A is inversely proportional to B. Whatever. That allows you to write the equation A equals KB or A equals K over B for inverse. And then you'll be given a pair of numbers that go together. For instance, let's say that I'm experiencing a force of 10 newtons when I draw the spring out a distance of 5 centimeters. Then I can rearrange this. Since I have K times X, and I want K by itself, I can divide by X, and I get F equals, F over X equals K. I can now calculate my constant of proportionality, the spring constant here, and so K is equal to, that's supposed to be at equals, not a Z, guys. So I have my force on top, so that's 10 newtons. And my distance on bottom, the displacement of the end of the spring from its natural position. And so 10 newtons divided by 5 centimeters is going to give me a spring constant. Hold on a second. That's a little too messy. I'm going to have to erase some of that. Might as well fix this one while I'm at it. Okay. I get a spring constant. 10 divided by 5 gives me 2. And a spring constant doesn't have its own special units. It's just going to be newtons divided by centimeters. And that's where we're going to leave that. Okay, that would be the first half of the problem, finding the K. So they would have said, the force is directly proportional to the displacement for a linear spring, and for a displacement of 10, or for a displacement of 5 centimeters, the spring will exert a force of 10 newtons. Then it will ask. What force would I experience for a displacement of 3 newtons? Or it may ask, how far do I need to displace the end to experience a force of 15 newtons? So let's do that last one. We have 15 newtons. Whoops, that's a mess. Let me erase that again. Okay. For a 15 Newton force, if I'm experiencing a 15 Newton force from the spring, how far have I displaced the spring? Well, in that case, we still have this equation is in charge, okay? F equals kx. But now we've found k from the previous set of numbers, and we're given the f, so we need to get x by itself. Well, if we're trying to get k by itself, we divide by x and move it over, which means if we want to get x by itself, we divide by k. And so we have f divided by k equals x, and that's going to give us 15 newtons of force divided by a spring constant of 2 newtons per centimeter. Can I come off the edge of the screen here? And that's going to equal 7.5. That's getting messy. Hold on a second. That's my eraser. Alright, let's try it again. There's my equal sign. And I have 7 points. That's supposed to be a decimal there, guys. Sorry. 7.5. And that's newtons divided by newtons over centimeters. So you flip the fraction on the bottom. The newtons will cancel, and we get centimeters. Okay? And that's how the entire problem would be. We'd first be told either the equation F equals kx, or the relationship force is proportional to displacement, which tells you mentally you translate into F equals kx. Then you'll be told a pair of numbers. You experience a certain force for a certain displacement, and you find the k, and then they ask you for the same spring, because the k will be the same for the same spring. For the same spring, what displacement would I experience, or would I have to put the end of the spring through in order to experience a 15 Newton force? Okay, or what displacement goes with a 15 Newton force? And you calculate this way. If they had asked me what force would I experience for a particular displacement, actually would have been a little bit easier. We just take the equation as it is, k times x, and find the force. Okay? Now the same thing applies with the others, so I'm not going to do the number part with the others. I may do one more. But I need to show you the other types of